Yelp visualization. Our goal was to implement data visualizations on Yelp data to improve the comparison and discovery of restaurants, to allow us to pick the right one for us. Many of the concerns regarding the current Yelp interface discuss the inefficiencies of text-heavy lists. Instead of using the usual search and filter tools, followed by lists of restaurants and lists of reviews, our visualizations convey important information faster and with fewer searches and clicks from the user. Our visualizations represent the restaurants on Yelp in different scales, allowing users to begin by comparing a large group of restaurants and quickly narrow down to a single restaurant. The Yelp dataset contains a limited number of restaurants for specific regions in the United States. We decided to include all of the data in the visualization tool for demonstration purposes. In practice, a user would only query restaurants within a certain distance of their location. When a user first enters our website, they're met with a map and a search bar. Our search bar uses a keyword search. When a user performs a search, the dynamic map updates with the locations of all of the restaurants, and a bubble plot with all of the results is pulled up. The user can examine the locations on the map by dragging, zooming in or out. Initially, the markers on the map represent the locations of all queried restaurants. However, after the user begins selecting individual restaurants, the map is updated to only display markers for selected restaurants, centered around the most recently selected. Each bubble on our bubble graph represents a single restaurant, with its X position representing the total number of reviews and the Y position denoting their star rating. The size of the bubble represents the average price of the restaurant, with the smallest circle denoting the most expensive restaurant, while the larger circles represent more affordable places. For example, we can see Rosalie Le French Café and Bistro Agnes have similar numbers of reviews and similar star rating, but their prices differ significantly. To learn more about a restaurant, a user can select the restaurant from the list of restaurants or click directly on the bubble. Selecting a restaurant will update the map with the restaurant location and also introduce a new visualization, a star diagram, which plots different attributes of the restaurant, such as review count, the number of days they are open, price, categories, and stars. We can also select multiple restaurants to compare by clicking the Select Multiple toggle button. The user can now select multiple restaurants from the list, and once selected, the map and star diagram will update. As stated earlier, our search is a keyword search, so for each restaurant, we have generated the top words associated with the restaurant. Our search stems and lemmatizes the input, so small spelling differences or different wordings will not affect search results. This allows users to search by dishes, names, or other attributes that they may be looking for in a restaurant. Such as birthday, pancakes, and for an example of words that are spelt slightly different, we can do fries and fry, and they'll show us the same results. An important part of Yelp are the reviews. However, this is where visualizations can especially cut down on reading time. Take a look at Shake Shack. Using the button Take a Closer Look, we can see a lot of the features of Shake Shack. Here we see the most common positive and negative things said about this restaurant. Positive comments are in green, negative in red, with the size and saturation of the bubble representing how positive or how negative the bigrams are. From these feature bubbles, we can see what may be good or bad about this restaurant, such as the Shack Burger being the most popular dish or there being a long wait time. For each restaurant, we removed stop words, stemmed, and lemmatized all of the reviews. On these processed reviews, we used a feature extraction module called TF-IDF Vectorizer, we considered all phrases that contained 2 words, or bigrams. We applied support vector machines on the transformed data, utilizing review ratings as the model's label to classify our bigrams. The bigrams with the 7 lowest scores and the 7 highest scores were then chosen to be displayed in the visualization. We can also use this visualization to compare multiple restaurants by selecting them. For example, now I'm going to click sauce and click take a closer look again. Here we see the same features of Shake Shack, but also we see the features of sauce, which seems to be popular with dipping sauces, cheese curds, and pork belly, but I don't think a lot of people like the waffles. Outside of the front-end visualization, much work was needed due to the size of the dataset. Our dataset was split into several collections and uploaded to MongoDB. Our backend server was implemented in Flask to allow for various queries to this dataset. These queries include querying restaurants by keyword, category, or name, querying reviews by business, and querying top positive and negative bigrams in reviews. In conclusion, our visualizations offer an alternative way to discover and compare restaurants. Thank you.